force is applied on it. Suppose it is asked the condition when work will be done, no right force is required. Okay. Work always done by a force. That is the important factor in this chapter. Which force is acting on the object, that should be identified. Right? So suppose you are holding an object. Suppose you are holding an object on your palm. So which force is acting on the body? Anyone?
The normal reaction force.
Yes, one normal reaction.
And weight of the body.
Weight of the body. And third, you can say the force applied by you, right, on the object to hold the object. So here we have seen three forces: normal reaction, the force applied by you, third is the gravitational force. Same object, same example, same situation, but work done by these different forces will be different, may be different. So always whenever you will find work, what is the force acting? Work done by which force? Is it gravitational force? Is it reactional force? Is it the weight? Is it the tension? Is it the frictional force? Which force is acting? That should be remembered before you calculate work. So I think all of you know that work will be done on the object if the force acting on the object will displace object. If the object will be not displaced, the object will not change its position, then there will be no work done. So all of you please note down. Work is said to be done. This is the definition of work. Work is said to be done by a force if the object moves in the direction of applied force. Work is force into displacement, right? Or W equal to Fs cos theta. W is the water, F is the force, S is the displacement, and theta is the angle between the direction of force. Remember the formula of work? Fs cos theta. The unit of work. So, this is work is in power. It's you and we interrelate this first. So to the next class. Now, the formula of work is Fs cos theta. How it is derived? You see the topic expression of work. You see the diagram. A block is diagram. A blue box is given. So a block is and for acting force applied on this object right side F, but the object is along the incline, right? Making an angle theta. So you please try to understand the diagram, then see the expression. The force F is applied on that object along right side. Okay, but the object is moving along the slope. making angle theta. Theta is the angle between the direction of force and displacement. Suppose the object is moving from A to C. So displacement is from A to C or S. Now see the equation. Displacement, the object is moving from A to C. The displacement is AC. Suppose S. Suppose you see that cos theta equal to or cos theta. AC means S cos theta. Right? So we can do S cos theta. Now see the formula of work is force into displacement in the direction of all of you see moving from A to C. Object is moving from A to C. In the direction of force, in the direction of F, the object displacement is AB. So force is F and the displacement in the direction of force is AB. How we calculate it? We get to S of the formula that F is cos theta. Object move from A to C, but in the direction of force, the object is moving from A to B. So displacement is AB here in the direction of force. So that displacement we have to take. Is it clear, all of you?
Yes, sir.
I want another confirmation from Nandini Jain. Is it clear? Okay, so all of you, please remember F as cos theta. So next slide. F as cos theta. This is the formula of work. The work is divided into three categories: positive work, negative work, and zero work. The first one is positive work. Right? The positive work, if theta is less than 90 degree, in your formula Fs cos theta, W equal to Fs cos theta. Okay. So if we put theta is less than 90 degree, theta is less than 90 degree. So if you take, anyone can tell me what is the value of cos less than 90 degree, suppose 60 degree. What is the value of cos 60 degree?
The 1 by root 2.
1 by 2.
1 by 2, yes. And cos 45 degree, 1 by root 2. Like that. But 0 to 90 degree, less than 90, up to 89.999 degree. Take any value of theta less than 90, the value of cos that angle will be a positive value. Suppose cos 60 degree is half, 1 by 2, that is a positive. Cos 45 degree, 1 by root 2, that is a positive value. So this is the condition that the work is positive. Okay. What is that condition? Theta must be less than 90 degrees. So let us see a few examples. Number one, positive work so many around you. Pushing an object by a force such that the object moves in the direction of force. So please give me the response. If the object is moving in the direction of applied force, what is the value of theta?
Less than 90.
Yes, less than 90 degree. Exact value? 50 degree, 60 degree, 45 degree, 89 degree, 25 degree. If the object moves in the direction of applied force, then theta is, nobody is getting, I think. Suppose the force is applied in the direction of the arrow. That force. The object is also moving in the same direction. The object is also moving in this direction. So what is the angle here? In this case, angle is 0 degree. Yes, 0. 0 is less than 90 degrees. So in this case, work is positive. Second, lifting an object from the surface by a person is a positive work. If you lift an object from the ground, in which direction the force is applied? Left, right, down, up. You are lifting an object from the ground. So in which direction the force is applied by you, by the person?
Upward.
Upward. And in which direction the object is moving?
Upward.
Upward. So what is the angle?
0 degree.
0 degree. That is less than 90. So work is positive. So before the start of this topic, I told you that the angle between the force and displacement must be known to you. In which direction, which force is acting on the object, that is important. Okay? Any doubt in this topic? Positive work?
No.
Next is negative work. Negative. If theta is greater than 90 degree, more than 90 degree, then the work is negative. Suppose the value of theta is 100 degree, 110 degree, 105 degree, 120 degree, 180 degree, more than 90 degree mean to say. So if you put cos 1, anybody know what is the value of cos 120 degree? Minus how much?
Minus 1 by 2.
Yes, minus 1 by 2. So we are getting minus. Okay, if theta is greater than 90 degree, then cos that angle will be a negative value. For example, cos 120 degree is minus half. Okay, minus half means 0.5. We are getting negative value. Cos 180 degree. Cos 180 degree का value किसी को पता है? Minus 1. Okay, like that. If you take any value more than 90 degree, the answer will be negative. So if your force subsequent displacement is 4 meter, right? And cos 120 degree, because of that minus, the work done is negative. Okay? So let us see a few examples of negative work. Very few in this category. Number one, work done by frictional force. And second, work done by gravity when an object is lifted from the surface of the earth. Right? How work done is negative in case of friction. Suppose an object is taken. An object is taken. All of you, please see the diagram I'm drawing here. It is placed on a surface. Suppose this is the surface on which the object is placed. The object is moving on the right side. If the object is moving right side, in which direction you will have the displacement? Displacement किधर हो रहा? Left side or right side? The object is moving right side, so displacement will be on right side. In which direction the frictional force is acting?
Sir, left
Frictional
side.
force.
Right.
Left side always
Left.
Yes. In left you have the friction. So frictional force is acting left side. Displacement is on the right side. So what is the angle in this case?
180 degree.
180 degree. Theta equal to 180 degree. Okay. So in this case, the work done is negative. Negative work. Okay. Another example, I give them lifting an object from the ground. Right. Once again, take an object. I've taken an object on the surface of the earth. This is the surface. So lifting an object, right, work done by gravity, in which direction the gravitational force acts on this object?
Sir, down.
You know, downward. Downward.
And down.
Weight and gravitational force same. So gravitational force acting on downward direction. And you are lifting the object. The object is moving up. The displacement is equal direction. What is the angle here between displacement and gravitational force? Just opposite is theta is it's 90 degrees.
So
That
many
90 displacement और force के बीच का एंगल किसी और चीज के बाद force और displacement के बीच का एंगल ये वाला है. This is the angle and which is 180 degree. So here the work done by gravitational force on lifting an object is negative. In the same example, if it is asked work done by a person to lift the object, the force applied by a person must be in upward direction. In the same example, work done by the person is positive, but work done by gravitational force is negative. Okay, in previous example, work done by friction. Work done by friction is if somebody pushes the object right side, the force is the right. Work by applied force is positive. So that's why I'm telling you so many times that which force you are using, that force is important. Frictional force acting left side, displacement is on right side, so angle is 180 degrees, so work done is negative. But on same object, suppose you are pushing, the force applied by you in the direction of displacement, then work done by you is positive. So here we'll take a 5 minutes break. We'll join after 5 minutes at 10:90. The condition is the angle theta must be greater than 90 degrees. Next is 0, 1. 0. There are two conditions of 0, 1. You can see first condition is when theta is 90 degree, and second is if there is no displacement. Okay? So there are two conditions of work to be 0. First is theta is 90 degree. If theta equal to 90 degree, and if we put W equal to Fs cos theta, it's the formula of work done. Put theta equal to 90 degree and see what will be the value of W. Anybody? If you put theta 90 degree, so what is the value of cos 90 degree?
0.
0. So if theta equal to 90 degree, then W will be 0. It means that work done is 0. Zero one. Second is the same formula, W equal to Fs cos theta as equal to 0. And there is no displacement. As 0 means no displacement. So what will be the value of W once again? W will be 0. So these are the two conditions that work done will be 0. If theta is 90 degree, and second, theta is there is no displacement. Let's horizontally with some load on his head, pulling on a horizontal road with some load on his head. See the load, right? The pulley is working on horizontal road, suppose moving right side, displacement in right side. In which direction is applying the force? The load is on his head. In which direction the pulley is applying the force?
The right side.
Right side. If you are holding a load on your head, in which direction you will apply the force to hold that load?
Sir, upward.
Yes,
Or downward.
upward. You must apply force in upward direction. Okay, force applied by you, force applied by the pulley. Right? The load is on his head, the force must be applied in upward direction. and the pulley is moving on horizontal road, right? So you can see the angle between force and displacement. Displacement on right side, force acting in upward direction. The angle is 90 degree and cos 90 is 0, so work done is 0. So work done by the pulley in this case is 0. The arrow indicating the pulley once again standing on a horizontal road. The pulley is moving left side. Okay. Displacement on left side. Pulley is moving. Now, question is open to the class. The pulley is moving left side. He is holding a load on his head. Work done by gravitational force. The box is the load. Pulley is moving on a horizontal. So what is the work done? This arrow the thick arrow indicating the pulley holding the load on his head. The pulley is moving left side on horizontal load. What is the work done by gravitational force? Positive, negative, or 0?
0.
Work done by gravitational force is 0. Because you know the displacement is on the left side and gravitational force acts in downward direction. So gravitational force will act in downward direction. So the angle you can see is 90 degree. So work done is 0. Right? So in this case, work done by the pulley and work done by the gravitational force is same, that is 0. Okay? Next example. The pulley is holding the load on his head and moving up steps. Moving from the ground floor to second floor. Moving upstairs. Carrying a load on his head, the pulley is moving upstairs. Positive, negative, 0. Anyone? The pulley, yes, it is positive. Yeah. The pulley is holding the load on his head, so the force applied by the pulley is upward direction, and the pulley is moving upstairs. So the direction of force and the direction of his movement or displacement is same or less than 90 degrees, so work is positive in this case. And in the same example, the pulley is holding the load on his head, moving upstairs. What is the work done by gravitational force?
Negative.
It will be negative. Gravitational force acting in downward direction and the pulley is moving up, right? So displacement is an upward direction, so angle is more than 90 degrees, so work done will be negative. So work done by which force, that is important. In same example, so many forces may act, but work done may be different by the different forces. I hope this is clear. Second example of 0 work, you can see a body moving in circular path. Work done by centripetal force is 0. I think all of you know what is the direction of centripetal force if the object is moving in circular path? What is the direction of centripetal force?
Toward the center.
Towards the center. And what is the direction of displacement at any point?
Along the tangent.
Along the tangent. Good. Suppose a body is moving in this circle. At any point, I choose a point. Suppose you see the black spot. That is the point. The object is moving in anti-clockwise direction, suppose. So at that point, the direction of velocity and displacement is along tangent. It's the direction of displacement at that point. And centripetal force at that point acts towards the center. So you can see the angle is 90 degree. So work done by centripetal force is 0. Okay? I take another example. If the object is at this position, okay, shown by another dot, orange dot. At that point, what is the direction of displacement? You know, along the tangent. This will be the direction of displacement shown by the arrow. And direction of centripetal force is towards the center. You see the angle is 90 degree. So work done is 0. The work done by centripetal force is always 0. Right? So question is, the moon is revolving around the earth in circular orbit. What is the work done by moon?
0.
0.
0. So any object moving in circular path, work done by that object is 0 because centripetal force acts towards the center. Second condition you can see, if there is no displacement, then work done is again 0. And this is possible if you apply the force on a very heavy object so that you are unable to move the object. Suppose you are applying force on wall, heavy wall. Force is applied, but you are unable to move. The object will not move. So in that case, work done by you is 0, provided you are applying force. Okay? The object will not move, so work done by the applied force is 0. Till now, anyone having any question or doubt?
In the previous example, the movement of moon around the earth, sir,
Yes.
the motion of moon is along the tangent. But sir, what is the force applied by moon?
The moon is revolving around the earth, and any object revolving, any object moving in a circular path, which force is responsible? Centripetal force.
Force, sir, but it is of the gravitation force of the earth.
The gravitational force of Earth provides the centripetal force. Right? Centripetal force will not come automatically. In last class I have explained. Centripetal force on the moving object will not come automatically. Some force must act on that object towards the center, and that force is termed as centripetal force. जो कोई force object के ऊपर लगता है and it is working towards the center of the circular path, that force is the centripetal force.
But it is the
Gravitational,
but it is the force applied by the earth and not by the moon.
yes, force applied by the earth on moon, and that force is responsible for the movement of the moon. Right? And that force is termed as centripetal.
Yes, sir. So the work done by the earth is 0, sir. But how is the work done by the moon 0? So when is
Listen here. Work done by earth, not earth. Work done by force. Which force?
gravitational force, centripetal force?
Yes. So centripetal force, work done by centripetal force, and that force is responsible for the movement of the moon. और वो force कहाँ से आता है? That force comes from gravitational force of Earth and Moon. So here, any object, not only Moon, any object moving in circular path, so we'll say that the work done by that object is zero. Because on that object, force is acting towards the center and its displacement is along the tangent. Okay? So this is the work and the three types of work and their conditions. Tomorrow you will have the test on first chapter. Okay, I'll take a small test, objective type, 10 questions, objective questions. So tomorrow I'll take a test. Okay then. Thank you very much to all of you. Have a good day.
Thank you, sir.